Yes. Right, like I was saying, in graphs, guys, the gradient and the area always represent something. And how do we know when the gradient represents what is by remembering the mathematical value of gradient, all right? I think you guys learned this in mathematics, right? What's the formula to find the gradient? No, y equals to mx plus c is a straight line equation. The gradient is which one? This one, right? This should be the gradient, right? So what's the gradient formula? Do you remember or not? M equals to
y1 minus y2 divided by x1 minus x2.
Excellent answer, Leo. It is y1 minus y2 over x1 minus x2, right? So from here, I ask myself, what does the y gradient represent? The y gradient represents the distance, the x gradient represents the time, right? In other words, can I say that since it is change in y over change in x, can I say that it is essentially the change in distance over change in time, right? So if it is distance over time, then what does the gradient represent? Speed.
Velocity.
Not velocity, displacement over time. If let's say this was a displacement over time graph, then yes, it would be velocity. But if it is distance over time graph, then naturally this one will be speed. So from here, the first thing I understand is that the gradient in a distance time graph represents the speed of the object, right? What about the area under the graph? What does the area under the graph mean? Now, let's say, for example, I help you guys visualize this. Pay attention now. If today I want to find the area under the graph, let's just say I want to find the area of this rectangle part here. Mathematically, area is x times y, right? Right. Everyone knows this one. In this scenario here, it is x times y. And since the x-axis represents the time and the y-axis represents the distance, can I say it's distance times time here? Distance times time will give me anything. Will it give me anything? No, it will not. Guys, this is a trick question. Distance times time will give you nothing. And because of that, the area in the distance time graph represents nothing. So if I want to identify the information here, right now, if I have a constant gradient in the first part here, it means to say I have constant speed. If I have zero gradient, it basically means that I have zero speed. And if I have negative gradient, does it mean I have negative speed? Is there such a thing as negative speed? Anyone tell me? Is there such a thing as negative speed? No, there is definitely no such thing as negative speed. And because there is no such thing as negative speed, then what does the negative gradient represent? What does the negative gradient represent? Anyone can tell me. Oops. The direction. Excellent, Raj. It is the direction, right? By here, guys, you should imagine what's going on here. Let's imagine initially this guy here started at position 0, right? And let's say this position here is position 10 now. Can you imagine that as he goes from here to here, he's actually walking from 0 to 10 meters, right? Right. Then after that, he stayed stationary here at the 10-meter mark. Mean to say he stayed here for a few seconds, right? And then after that, he decided to go from here back into here again, which is at position 10 back to position 0, right? Doesn't this mean that if he's going from position 10 back to position 0, he's actually moving in a backwards direction? In other words, this guy here is actually moving backwards, guys. He's actually moving backwards as the distance time graph goes back from 10 to 0. You understand? In a negative gradient, the distance time graph means to say that the guy is actually moving backwards. Okay, this is the first part. Anyone's got any questions for this one here? Okay, everyone understand this? Let's go into a more common IGCSE question. Let's imagine today, instead of a distance time graph right now, I have a velocity time graph. Same thing lah. The velocity time graph has one straight line upwards, then one horizontal line, then one line that goes downwards like this. Okay. Yet again, whenever we talk about graphs, the gradient and the area is supposed to represent something. The gradient and the area is supposed to represent something. Okay. This time around, what does the gradient represent?
Acceleration.
Good. It is the acceleration. How do I know this? Because yet again, this is the gradient now is change in y over change in x-axis, right? If it's change in y over change in x-axis, in this scenario here, it will be change in velocity over change in time. Acceleration's formula is what? Is v minus u over t, right? This is essentially the change in velocity, right? This is obviously the time taken. So from here, I know that the gradient represents the acceleration. In a sense, if I have a positive gradient, then I have positive acceleration. If I have negative gradient, if I have zero gradient, then obviously I have zero acceleration. And when I have negative gradient, what does it mean? Negative what? Negative acceleration is known as what? What does
Slowing down.
Yeah, it is slowing down. In other words, it is known as deceleration, right? Deceleration is essentially the slowing down of the object. So from here, I know that based on the gradient formula, the accelerations are going to tell me different things depending on how the graph is supposed to look like, right? Then from here, if I want to find the area, yet again, if I want to find the area this time, area under this graph here is essentially going to be my y multiplied by my x, right? My y multiplied by my x, which is yet again going to be velocity multiplied by time. This time around, what does the velocity multiplied by time represent?
The displacement.
Good, excellent, Raj. This time it is correct. It is going to be the displacement. Why is it displacement? If let's say this was a speed time graph instead, then the area will be distance. But since this is a velocity time graph, then the area will be the displacement. In other words, the area here will represent how long or how far the object has traveled. Right? These are the basic stuff that you should know. And then one more very important question that is always going to come up in your exams as well. Let's imagine today I have two scenarios. One scenario where there is no air resistance. Okay, if there is no air resistance, if I have a ball that is falling downwards, guys, if I have a ball that is falling downwards, what will be the only force that acts upon it?
Gravity. No.
Yes, it is. You're correct, Leo. It is going to be gravity, right? The only thing that acts upon it is going to be gravity, right? And gravity is obviously going to be affecting the weight of it now. Weight is essentially going to be a force. If today we know that the only thing that acts upon it is gravity, and we also know that gravity's constant is 9.8 meters per second square. This means to say that every second that goes by, the speed of this object is going to increase by 9.8 meters per second, right? Still using time? Senator Alice Smith, you're in Alice Smith, right? 10? Year 10 就是use 9.8 了。But your syllabus has changed. When you do the form exam and everything, make sure that the gravity is 9.8. Right. So because it is 9.8, it means to say 9.8 meters per second square means to say every second that goes by, the speed increases by 9.8. Meaning to say, if I were to draw a velocity time graph, guys, if I were to draw a velocity time graph, every second that goes by, right, the speed increases by 9.8. Then obviously the second that comes by, it will be like 19.6 and so on and so on and so on, right? So the graph will essentially look something like this, right? The graph will be like one direct straight line because the only thing that acts upon it is gravity, and gravity accelerates the object constantly, so the speed keeps increasing constantly as time goes by as well, right? This is the understanding of gravity, But what if there is air resistance right now? Today, I say that this scenario, there is air resistance, and the same thing, the ball is falling downwards. Okay, as it falls downwards, the same application applies. Well, right, I know for a fact that as the ball falls downwards, the only thing that acts upon it is going to be gravity downwards, right, which is responsible for the weight of the ball. What other force is acting on the ball?
Drag force.
Yeah, air resistance or air forces, right? And the air resistance is obviously going to act in the upwards direction. But let me ask you this. Does the air resistance change or not, guys? Will the air resistance change as the thing keeps falling?
Yes,
Why? Why will it change?
because as the acceleration, gravitational acceleration is 9.8, the velocity is going to increase by 9.8 meters per second. So as the speed increases, more particles are colliding at a faster rate. So the air resistance also increases.
Excellent answer, right? That is essentially what we are using here. Guys, we must remember air resistance is directly proportional to your speed. Meaning to say, right, if you imagine this, like sitting inside a car and open the window, right? When the car is not moving, you don't feel any air resistance acting on hand, right? But as soon as the car starts moving, you feel that there is damn a lot of air resistance acting on hand, right? This is simply because air resistance, guys, air resistance is directly proportional to your speed. Meaning to say, the faster your speed, the greater your air resistance. And what's going to happen here is, right, since we understand that the air resistance increases with your speed, as the speed of the ball increases, let's say the speed of the ball increases, right? As the speed of the ball increases, the air resistance is going to act and increase oppositely more and more and more and more. This air resistance will keep growing, guys. The air resistance will keep growing until the air resistance upwards, the force of air resistance upwards is equals to your weight downwards. When your air resistance is equals to your weight, what's that phenomena called again? When your air resistance acting upwards is equals to your weight downwards, what's that phenomenon called?
Constant speed.
What? Sorry, say that again.
Constant speed.
Constant speed. Yeah, in other words, it is actually called terminal velocity, guys. Remember this phrase or not? Terminal velocity basically states that there is going to be zero acceleration at this point. Zero acceleration is simply because there is no resultant forces acting on the object, right? Remember the F equals to ma formula or not? F equals to ma formula states that in order for an object to accelerate, there must be resultant forces acting on the object. In this scenario here, there is no resultant forces. In other words, there is no acceleration. This term is what we call terminal velocity, guys. All right. And terminal velocity means there's going to be zero acceleration. So if I have a graph of velocity versus time, guys, how would the graph look like if I have a velocity versus time graph? Will it curve upwards? Will it go straight? Will it curve downwards? Or will it eventually curve to become a flat line? Which one will it be? The third one, guys, right? It's supposed to be the third one because if I have a velocity time graph, initially you see that I have a curvature. A curvature means to say that the gradient here, guys, if you notice here, the gradient from here to here, the gradient is actually decreasing, right? Decreasing gradient means to say there is decreasing acceleration, right? Decreasing acceleration all the way until the acceleration is flat line here. This is where we call terminal velocity, when the acceleration is going to be zero here. Okay, very, very important. Oh, one more question I want to ask everyone, guys. Is decreasing acceleration the same as deceleration? Is it the same? Anyone can tell me this one?
No.
It is not. What does decreasing acceleration mean?
Gaining speed at a slower rate.
Very good, Shihin. That is absolutely the answer, guys. For those who have a hard time visualizing what decreasing acceleration means, it is still accelerating. Accelerating means to say the speed of the ball is increasing, right? But at a decreasing rate. That's what we call decreasing acceleration. If I were to put numbers in it now, initially the ball was moving at 10 meters per second. 10 meters per second. Then it goes to 20 meters per second. Then it goes to 25 meters per second. Then it goes to 26 meters per second, right? You can see that each time the jump of the speed is actually decreasing, right? Each time the jump of the speed is decreasing, this is what we call, this whole scenario is what we call decreasing acceleration. It is still increasing speed, it is still accelerating, but at a decreasing rate from 10 to 5 to 1 obviously. You can see that this is what we call decreasing acceleration. Alternatively, it's true as well. If today I have increasing acceleration initially from 10 meters per second to 20 meters per second to maybe 40 meters per second to maybe like 100 meters per second, right? You can see that each time the jump is actually increasing more and more and more and more, guys. This is what we call increasing acceleration. This is what we call decreasing acceleration, guys. Very important. You must know this. Must know this. Okay. Then after that, before I proceed on, anyone's got any questions for this part? Any questions for this part or not? If you want my scribbling, you can let me know later. I can take a screenshot, but looks kind of ugly. Okay, right. Moving on. Next thing I want to talk about is basically going to be about the Hooke's Law chapter, guys. Anyone here can define me Hooke's Law or not? Anyone can define me Hooke's Law? Hooke's. Oh, deceleration is like from 100 meters per second to 50 meters per second to 25 meters per second. This is deceleration. The speed is decreasing. This is decreasing acceleration. The speed is still increasing, but at a decreasing rate. You see the jump here becomes less and less and less already. This is what we call decreasing acceleration. Now you know, right? So very important. It's a different thing. Right. But anyways, back to here. Hooke's Law. What does Hooke's Law state again? What is Hooke's Law about? What is Hooke's Law about again? What does it talk about?
I remember. Okay, to give a bit of basic summary, the spring it's like in a normal, it's in the original distance. If you put a heavy object, it extends, right? The spring. But over time, if you take out the heavy object, the spring was like extended a bit. The distance has increased slightly.
Okay, let me stop you there right there, Leo. You have the right concept in mind, in the sense that if imagine I have a spring here, right, and then I put a load onto it, obviously this spring is going to elongate, right? And then this is where you got it wrong, Leo. If I let go of this load, right, this spring is actually going to bounce back to the original position. If I put a heavier load, it will extend even more. If I let go, it will bounce back. I can keep doing this all the way until one point. What's that point called again?
Elastic limit.
Yes, it is called the elastic limit. Once you exceed the elastic limit, only when you exceed the elastic limit will the spring deform permanently and no longer return to its original position. So if I were to think about the graph, guys, a graph of a spring, it will look something like this. If I have a force versus extension graph, what's going to happen is, If I apply a certain force, it will extend a certain amount. If I apply a greater force, it will extend a greater amount. If I apply an even greater force, it will extend a greater amount, right? All the way until one specific point only. That one specific point is known as the elastic limit. Once I reach the elastic limit here, we call this the elastic limit. Once I reach the elastic limit here, what's going to happen is it will start to no longer behave directly proportionally. Instead, it will just wait. Yeah. So if you exceed this elastic limit, what happens is the spring will deform permanently and it will no longer be directly proportional anymore. It's just going to like bend and koyak already lah. Basically, the spring is koyak already lah, right? So from here, right, if you can remember this graph, you can actually bullshit your way through the whole Hooke's law. Listen up, guys. I'm going to type this down later for you guys as well. Hooke's law states that the force on the spring is directly proportional to the extension exerted on it, provided that the elastic limit is not reached. Right. In other words, I can say that this part here obeys Hooke's law because the force is directly proportional to the extension, right? And this part here does not obey Hooke's law, guys. This part here does not obey Hooke's law because the force and the extension is not directly proportional. Okay, so from here, I can start my statement more. Hooke's law states that Hooke's law states that the force exerted on the spring is directly proportional to the extension provided. Where it does not exceed the elastic limit. This is essentially what you're supposed to say, and guys, Hooke's law states that the force exerted on a spring is directly proportional to the extension provided it does not exceed the elastic limit. This part here obeys Hooke's law. This part here does not obey Hooke's law. How about the formula, guys? What's the formula for Hooke's law again? Anyone can tell me?
F equals to kx.
Good, excellent. It is F equals to kx. F equals to kx. Obviously, this is measured in newtons. This is the spring constant measured in newtons per meter, and this is obviously the extension measured in meters. Huh? You want to write down? Later, I'll just screenshot for you. Then I can send it to you. Actually, yeah, later I'll send it to you. Okay, very important. This one here. Then after that, another very important chapter, which is going to be your moments. The bane of all evil, moments. What is moments? Bear in mind, guys, I have some students until this day, they're telling me that moments is the same as momentum, guys. Is it the same? Is Ken the same as Kenneth or not? It's definitely not the same, right? Bloody hell. How can you guys mistaken this? Moments, guys, is essentially a turning effect, due to a force, right? Whereas this momentum here is the inability for any moving object to stop moving or any stationary object to start moving, guys. Momentum depends on two things, right? Mass and velocity, whereas moment depends on the force and perpendicular distance to the pivot. Very different things, guys. Don't mistake it for some reason. Okay, guys, how do I know when the question is asking about a moment question? A moment question for sure will have a pivot in it, guys. If you see the word pivot in it, God forbids you do a momentum formula, right? As soon as you see the word pivot, this is a keyword to indicate that it's going to be a moment question. Right? You remember, everyone, right? So if we talk about moments more, guys, obviously just now, like I mentioned, the formula for moments is going to be force multiplied by perpendicular distance, right? But there is something wrong with this formula. Not something wrong, like something weird about this formula. What's the formula for work done, guys? Do you remember the formula for work done? What's the formula for work done?
FD cos theta.
Is yet again force times distance. So, guys, let me ask you a question. If moments is force times distance and work done is force times distance, are they the same thing? Why not? Why not? What's the difference between them? Can anyone
The
tell me?
distance in moment is the perpendicular distance.
Good, very good, Raj. It is moments, it's actually the perpendicular distance, right? Whereas work done, the force and distance must be parallel to each other. For example, we're talking about moments. The most common example of a moment is a seesaw, right? Today, if this is the force, right, this here will be the distance, and this distance is very specific. It must be perpendicular. Number one, it must be perpendicular, and number two, it must be from the force to the pivot only. A lot of students, they always mistaken this. They always tell me that, oh, it is the force to the force or the force to some random thing guys. No. Moment is force times perpendicular distance to the pivot. Always from the force to the pivot is the distance, not the other way around, right? I mean, not some other funny way that students always give me, right? Whereas work done, guys, the force and distance must be perpendicular. For example, if I apply a force onto this brick or block or whatever, right? And this brick or block travels a certain distance, then yes, if they are both parallel, the work done will be there, and then obviously you'll be measuring work done in joules, right? Moments is going to be in Newton meters, guys. Moment is Newton meter, work done is in joules, right? So if let's say guys, I go into a calculation question. Let's do a simple calculation question today, guys. Let's imagine today there is a plank here, and there is a pivot here. Let's imagine I have one force that acts here, and one force that acts here, and then one more force that acts here. Let's imagine this is 30 newtons, and then here to there. Here to here is 3 meters, here to here is 2 meters, and here to here is 4 meters. Will this say that this force here is, let's just say 14 newtons? How much force will be required here? Hey, everyone, do this. I'll give you 5 minutes to attempt the answer. For those who have the answer, please PM me. I want to know how fast and how accurate you do. So what? 90 near 90. Without any calculation, on your calculator, for sure not going to be 90. How do you get 90? Let's see who has a fast and accurate answer. That's my what about? Wow, good times only, baby. Xuan, what is my answer? How much? 15. 15. Show me over here. Anh ơi sẽ được anh. Gì quá, không có kênh điện. Ở đây không. Three, xem. Wow, no one can do this. I'll give you a hint, okay, guys. First and foremost, you're supposed to find how many anti-clockwise are there and how many clockwise are there. Yes, correct. That's moments in equilibrium. The anti-clockwise moments must be equal to the clockwise moments. Then how? Then how do very long, but doing. And Jen, but they were alone. Oh. Hey, no one online can answer this also. I'm a bit surprised, huh? But you know what? I'm more surprised. I'm more surprised that so many students are here today. You guys really love my class, huh? I don't care what students come up. Because I think they either skip the event or they love physics too much. Oh, okay, got it. Okay, got it.
How about that? Math class coming up.
The rest is doing better. The math class and the rest is doing better.
We don't want to had registered by
That's sorry. Sure. Cái này ai còn yêu bốn? No. Okay, forever. Wow, lost day, everyone. Okay, guys, this one here is essentially going to be moments in equilibrium, right? What does moment in equilibrium state? The total anti-clockwise moments must be equals to your total clockwise moment, right? Right, everyone remember this, right? So how many of them are anti-clockwise and how many are clockwise? This one here is for sure. This force here is going to generate clockwise or anti-clockwise. This is clockwise. This one, or how come it's clockwise? You know how it spins or not? This is the pivoting point. Then this thing is going to spin like this, right? So this is going to be anti-clockwise, right? Let's put an A here to represent anti lah. Then this one, What is anti-clockwise or clockwise? This one is clockwise. Anti or clockwise, which one? It's guessing game, this one. Exam no guessing game, Which one? Clockwise or anti-clockwise? This one. Think about it, Shen. This is the pivoting point. If I have a force acting here, how would? Yes, this will be anti-clockwise, right? Because it's gonna spin like this, right? Then finally, this one here will obviously be anti-clockwise. Yeah, it is clockwise. Why? Because according to this pivot, this thing will spin like this, right? Right. So I identify that, oh, this is anti, and this is clockwise. I put it into number, I put it into my formula, right? The formula will be F1. You know already, Okay, everyone, I'll review this formula also. What's F2D2 equals to F3D3, right? Everyone, do your calculation. 28, Maybe it's correct. I'm not sure. Press it first. Xuan, press it first and see what's the answer. Find me the force. Find me the force. You stuck? What the hell? Huh? Ui. Give you this formula you cannot do I really. What's the working? Your force one will be this, right? So it's going to be 30, right? Multiply by your distance one is going to be a 3 meters, right?
Yeah.
Plus with your force 2, which is going to be a 40, right? And your distance 2 will be how much? Then after that, you're looking for force 3, ma. I don't know what force 3 is, right? But I know the distance. How much is the distance? 4. 4. 4. 4, 6. Why 6? Why not 4? Pivot. Yeah, this is the pivot. A lot of students like to give me 4 as an answer because they see 4. But 4 is force to force. I want force to pivot, right? Force to pivot, which is essentially going to be 6. If you press everything in your calculator, how much? Yes, very good, Leo. You are the only one that got it. Wait, this one is very important, guys. I don't know why a lot of students they kind of struggle a little bit with this chapter here. I can tell you, right, the trick to do this question is just remembering that if moments are in equilibrium, right? Then the total anti-clockwise movement must be equal to the total clockwise movement. Then after that, it's just up to you to interpret how the graph and everything is going to look like already from here. You understand or not? Huh? Wait, everyone online understand or not? Anyone confused with this calculation or not, guys? Anyone confused with this calculation? Okay. I want to give you guys one more question to do, okay, since we're on this topic. And I know a lot of students, they cannot do this question. Let me see. This one. Good. Hey everyone, use the remaining time to do this question and tell me what the answer is, everybody. This is a real IUCSE question, guys. Tell me what the answer will be. Everyone do this right now. You will be required to do some working to do this calculation. Please read the question carefully and everyone do this right now. Anyone's got the answer or not? Wait, do some working lah, just looking at it, it's not gonna work. Write down the basic thing. What did I say? Moment in equilibrium states, what? Write this down on a piece of paper. Use it as working faster. Write down the working. You're staring at it is definitely not gonna help our boys and girls. Let me repeat, staring at it is definitely not. But use the word as working, I'm not look at the paper. Use the back of it as working, your empty space, write something. I'll throw this away already after this, faster, use it, tell me what's the answer. Do some working and show me something. Wow, no one knows how to do this kind of questions. Jaden says it's C. Maybe you're correct, maybe you're wrong, but let's wait for the rest of them. I'll tell the answer in another 3 minutes, guys. In another 3 minutes, please attempt it right now. Anyone else wants to submit their answer or not, guys? "20 newtons. Definitely wrong. There's an exact answer here. Xuan, are you absolutely lost? You do not know what to do at all for this question? 20? How did both of you guys get 20 and there's no answer on 20? Ladies and gentlemen. Guys, let me show you how to do this question, okay? Please pay attention. It says that this beam here is a uniform ruler of 100 cm long, right? And weighs 4 newtons. First and foremost, if this thing is 100 cm long and weighs 4 newtons, where should the 4 newtons be acting on? Right, where should the 4 newtons be acting on?
50 cm.
Yeah, at the center. Good. That's why it's called a center of mass, right? Right? It's 4 newtons. And it says that the beam is rested on a pivot of 60 cm. 60 cm away, this pivot is here. And an 8 Newton load hangs here, right? The beam is kept balanced by a force F that is on the 80 cm mark, right? This force F keeps it in balance. What's the magnitude of F? Same thing lah. First and foremost, you need to identify which one are clockwise and which one are anti-clockwise, right? How many anti-clockwise and how many clockwise here? How many guys? How many anti-clockwise and how many clockwise here? Anyway. Everyone. Wait. How many of you guys don't know how to identify whether it's clockwise or anti-clockwise? How many of you guys do not know how to identify whether it's clockwise or anti-clockwise? 2 anti and 1 clock. Yeah, so this one will be anti, this will be anti, and this will be clockwise, right? So from here, if you have identified this, same thing I keep telling you guys, right? It's the moments in equilibrium formula, which states that the total anti-clockwise moment must be equal to your total clockwise moment, right? From here, so there's 2, right? So F1, sorry? Because this is the pivot, right? This is the force acting this direction, right? Right. It's equals to F3D3. Now, the difference of F1D1, which is this one, plus F2D2, which is this one, is equals to F3D3, which is this one. Right? And from here, it's just a matter of substituting all the numbers in, right? The first one will be 8 newtons. The distance will be how much? 60. Here to here, what, hello? 50, yeah, it's 50, right? Then plus my F2, which is 4. How much is the distance? 20. 20. Why 20? Why 20? This is here to here is 50, right? And then here to here is 60, right? Shouldn't this be 10 only? That's why you got it wrong, right? You thought it was 20, but this is actually just 10. The paper looks a bit like everywhere already, but you know, right? You know what I'm talking about, right? It's supposed to be 10, right? It's supposed to be 10 here. Then after that is equals to your force, and your D3 is how much? D3 is here to here, right? Which is obviously your 20, right? Press this into your calculator, you'll get like 440 is equals to 20F. From here, your F would have been 22 newtons. A very good, Jaden. Fast and accurate answer. It is absolutely correct. 10 for D2 is because this is the force mark, right? This is the distance, right? This distance, I know that this is center, right? Center means to say here to here is 50, right? Then here to here, they give me 60 already, right? Then obviously here is like 10 now. You see it or not? Okay, I rub everything away. Oh God. You see it? This is my F1. This is my D1, which is going to be 50. This is my F2. This is going to be my D2, which is going to be 10. This is my F3, and this is my D3, which is going to be 20. So the working will be like 8 times 50 plus 4 times 10 is equals to F times 20. And first, everything in the calculator with algebra, assuming that you know what algebra is going on, how algebra works, right? The answer is going to be 22. I lost. Which part I lost? Tell me which part I lost. 10 here. This whole thing is 60, right? Right, this whole thing is 60, right? And I know that this is the center, right? This whole thing is 100 cm, right? That means to say here to here is 50, right? And here must be 10 now. Right. Hey guys, This kind of questions is very important. Always comes out in the exam one. But must know how to do, guys. It's a must. Must know how to do. Okay. Okay, guys. Is there anyone with any questions on him? Couldn't do this. I'm very glad, Jaden. I'm very, very glad that you would manage to solve this. Excellent job. You a bit later, huh? But at least you got the answer. Okay, guys. Yeah. If you have no questions, that is going to be it for today, guys. Next week, when we come back, we're going to do the new chapter already, guys. Last week, we actually went through the charges. I'm supposed to go through the exercises with you guys, but a lot of students are not here today, so we don't proceed on. But next week, we're going to continue on with the booklet already, guys. Okay? So, yeah, having said that, if you have any questions, you're more than welcome to stay back. But if you have no questions, that will be it for today, guys. I'll see you all next week.
Bye.
Bye-bye.